I welcome guest of honor, Professor K. Ramugaru, Secretary of IGS Kakinada Chapter, Professor of Civil Engineering, UCK, JNPK. Due to his today's guest of honor, Dr. SRK Reddy Garu, Agent Civil Engineering, Godulwalleri Engineering College, Godulwalleri, onto the dais. I request Raja Garu to give bouquet. Now, welcome our another distinguished speaker and guest of honor, Engineer L.S. Subramanian Garu, DE R&B NS Division, Kakinada. I request Engineer Rambabu Garu to give a bouquet. I request today's sponsor, Crack Processing Systems Private Limited, Bharat Reddy Garu, who have generously come forward sponsor for the whole event. I request Bharat Reddy Garu to come onto the dais. I request Jyotiraj Garu to give a bouquet. I now hand annual proceedings to the proceedings of the function chairman Badam Sundarrao Garu.
Good morning to all. Today's function will start with prayer.
गीतसाराय गीततत्त्वाय गीतकोत्राय धीमहि गूढगुल्पाय घण्टमत्ताय गोजयपदाय धीमहि गुणाधीशाय गुणप्रविष्टाय धीमहि गदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि एकदन्ताय वक्रतुण्डाय गौरीतनयाय धीमहि गजेशानाय बालचन्द्राय श्रीगणेशाय धीमहि
Now, lighting of lamp. Thank you, sir. Now I request Engineer Durga Prasad to give a brief note on the seminar.
Today's seminar on Foundation Practices NSFP 2022 organized by Association of Consulting Civil Engineers India, Kakinada Center and Indian Geotechnical Society, Kakinada Chapter, sponsored by Crux Processing Systems Private Limited, will be conducted in three spells. The first session will be Soil Structure Interaction by Dr. S.R.K. Reddy Garu, Adjunct Professor in Civil Engineering, Gudlavalleru Engineering College, Gudlavalleru, followed by sponsors presentation, Crux Processing Systems Private Limited, and another talk by Engineer L.S. Subramanian Garu, Deputy Executive Engineer R&D, NS Division, Kakinada, on the topic Pile Foundation, a case study, and also the problems being faced in Roadcom Rail Bridge, which is also a practical oriented lecture. I hope the two lectures will give you good knowledge on this topic and wish it all success. Thank you for giving me this opportunity. Now, I welcome Badam Sundarao Garu, President message on this seminar.
Thank you, Durga Prasad. Today is a very auspicious day. Our chief guest and our guest speaker are the students of Dr. Reddy Garu. This is a rare event where the old students who are in a very good position have met at the same place. It's a privilege for us to make it happen. Actually, from Association of Consulting Civil Engineers, since inception, we are conducting regularly every month one either webinar or seminar. It is a part of that, and I am very happy to see you all here for enhancing your knowledge in civil engineering. Now, I request our guest speaker Reddy Garu to say a few words.
Respected Vice Chancellor of JIT University Kakinada, Dr. G.S. Prasad Raj Garu, respected President of Association of Consulting Civil Engineers India, Kakinada, Sri Badam Sundarao Garu, Durga Prasad Garu, and my another keynote speaker, Dr. L.S. Subramanian Garu, and other faculty members, research scholars, engineers in practice, and research scholars, and other dignitaries on the dais and before the dais. Very good morning to you all. It gives me immense pleasure to share my presence on today's event organized by both the Association of Consulting Civil Engineers India, Kakinada chapter, and also Geotechnical Society of Kakinada unit. In fact, these type of seminars or workshops will fill the gap between the theory and also the practice, particularly the faculty working in universities or colleges and the practicing engineers So what is going on in practical side, and what are the advancements that are taking place in civil engineering, particularly in structural engineering. So these type of workshops will definitely help all these civil engineers to the great extent. I tell you one thing before I close. Coming to the design of civil engineering structures or construction of civil engineering structures, so many new technologies have come, so many new materials have come. Therefore, it is our duty to transform the knowledge to the construction people, to the construction site. So that is very, very important nowadays, because every time, whenever there is a change, or whenever there is an earthquake, for example, or whenever there is a large scale tsunamis or cyclones, IS codes are being revised at least for every 5 years. Therefore, we have to follow the latest IS codes and the latest technologies, and for that, these type of seminars will definitely help all of us. I really thank the organizers, particularly Padam Sundarrao garu and also Durga Prasad garu, for giving me an opportunity to share my knowledge for all of you. And I trust this seminar or workshop will become a grand success, and you leave this hall with a lot of volumes of the civil knowledge. Thank you all for giving this opportunity.
Thank you, sir. Now I request Sri L.S. Subramanian garu to say a few words.
Respected dignitaries on the dais and my dear friends and colleagues from the departments and other various other organizations. It's indeed a great pleasure for me to share the dais with my friend and Vice Chancellor, Dr. G.V.R. Prasad Raju. And we were taught structural engineering by Professor Reddy. We both were his students. So it's a very nice time for me and for both of us to share the dais with him. And as rightly pointed out by Dr. Reddy, that theory is something different which everybody will preach. But when it comes to practicality, how much theory has been put into practice, that shall count a lot. The number of hours together you go on discussing theory, it may not serve you that important. But when you really see what happens in the site, that counts. Today I'm trying to show you whatever little I have, my knowledge goes into the practicality of two different aspects. One is a pile foundation, where we had tasted both a success and failure in pile foundations. And as well as one more interesting topic, though it may run into a bit number of slides, a little number of slides more, I'd like to showcase the problem being faced by the road cum rail bridge. Actually, everybody thinks that the department responsible for the maintenance of the bridge is not taking care of that. It's not that. It is not that, kindly. You will appreciate, after you see my presentation, you will appreciate what the problem really is. And now it has become it has reached a stage where nothing can much can be done. Just by with this few words, I thank the organizers, Dr. Sundara Garu, Durga Prasad Garu, for giving me this opportunity. Thank you very much.
Thank you, Subramanian garu. And now I request our beloved Vice Chancellor. Now I request our sponsor, Mr. Bharat Reddy, to say a few words.
Good morning, everyone. My name is Bharat Reddy, Digital Manager of Practice Private Limited. So, we are specializing in question setting slabs. We have prepared a small presentation. That one, why you have to go PT, what is the difference between the conventional
Thank you, Bharat Reddy garu. Now I request our beloved Vice Chancellor and Chairman of Indian Geotechnical Society to say a few words.
The president of today's wonderful workshop and thought-provoking and the order of the day which is required for the engineering community. Badam Sundara garu, a good friend of mine. I hope that he is shortly going to become Dr. Badam Sundara garu. And my teacher who taught me the structural engineering and also a part of that multi-story buildings and we are really fascinated. We are really loved at the time to hear his lectures. And at the time there was some problem in some subject like steel structure, something like that. And again he came to the class and he has taken that subject also. We are really happy with his not only teaching activity but also very friendly person to the student community. Another good friend, Subramaniam, we often call him as Subhu, and who are BTech classmates and benchmates and whatnot. And he is very close friend to me, and also incidentally, he is also my student, and student means PhD scholar, and has good capabilities, and he's doing very good for, particularly some of the very interesting areas, and we are taking his help for university. For example, Badam Sundara garu and L.S. Subramaniam, they have been helping us quite a lot for some of the developments in our university and the latest cement concrete roads. And this is a 30 years old problem for JNTU Kakinada, a year-long program. And we could able to, because of the help from Badam Sundara garu and L.S. Subramaniam, we could able to solve the problem, and we have gone for a tender for laying of cement concrete roads along with drains. A long time cherished for me. Even I have been working here for the last 33 years. And this is a dream for me, even though I work in different capacities in the university. But my aim is to have a wonderful facility in addition to convocation hall and big hostel building, in addition to normal buildings here. I like to have some cement concrete road with good drainage facilities. And for that, the two persons who have been helping me, particularly those two, are really appreciate their efforts. And the other student, Durga Prasad, and also I thank the Bharat Reddy garu who has sponsored the entire program. And from the IAS Kakinada side and Badam Sundara garu side, we are happy to have such a wonderful program here, and we have a lot of students here. Chandrasekhar ఏదో మొబైల్ చూస్తున్నాడు కానీ స్టిల్ హీస్ లుకింగ్ యంగ్ అండ్ హీస్ లైక్ బలరామ్. అంటే ఆయన మొబైల్ చూడటం వల్ల అంత యంగ్ ఉన్నాడు తెలియదు కానీ కంటిన్యూస్లీ. అండ్ పరశురామ్ ఉన్నాడు, గుడ్ ఫ్రెండ్ టు మీ. అండ్ ఈవెన్ సత్యనారాయణ ఉన్నారు, చాలా మంది తెలిసినారు అందరూ. సత్యనారాయణ ఉన్నాడు, తర్వాత Dayakar is there. Dayakar is really a person who is with me from so many years, and he's also helping for IAS Kakinada chapter. Ramu was there because of some work, domestic work. He was unable to be here on that day. And Narsiraw ఉన్నాడు, అందరూ వచ్చారు కానీ ముందుకు నరసింహరావు రాలే. ఆయన దగ్గర నేను రావాలి కానీ ఆయన రాలేదు. కూర్చోండి. So and lot of good friends are there. Satyanarayana ఉన్నాడు, మన రాధాకృష్ణ ఉన్నాడు. Lot of good friends are there. I'm really happy to meet you all. So because of some pressure in domestic work, I could not be able to come in time. I apologize for that. But really, I'm extremely happy to stand before you. A lot of research is going on. On innovative materials, innovative methods. I have been working in some of the areas, but anyway, the form is open for our student and teacher. It's a good combination. And the teacher is delivering the expert lecture on the same dais. The technical expert, another technical expert is L.S. Subramaniam. He is also delivering a technical talk. maybe a little, maybe slightly afraid because he's facing his own teacher. And but okay, he's also very strong. And anyway, thank you all for your nice presence. Because on the other form, I will talk to you separately. And we have been a number of, number of areas there, and research areas are there. You have been working in the area of expansive soils and waste material, implementation of waste materials, all these things, and everything is there. But let us say this form is open for two identified speakers. And once again, thank you for you all for your gracious presence. And we should have much more workshops like this. And there are some innovative areas and emerging areas. One area, even a lot of even Kakinada public is struggling is the road which is going from Kakinada to the beach road. Whatever the road we have, beach road is completely erosion and the complete sliding water and ఎప్పుడు కూడా రోడ్ వేస్తున్నారు. Again, it is not withstanding whatever the methods we have applied and whatever the techniques we have applied, still it is a challenging problem. And because of the presence of marine clay or the movement of sea water, whatever it is, the road is not withstanding so many years. And a lot of problems are there really, not only geological problems but also structural problems are many. And we have a monuments, engineering monuments, huge buildings are there in America, and underground construction, underwater constructions are there, and a lot of activities are there, and engineering marvels are there. So really, one should take up the challenges. And for example, you want to have some multi-story building, maybe 10 to 15 floors, and people are not coming forward to have such a high-rise buildings. It is really necessary. Even Hyderabad also, they are going ahead for some number of floors, not the floors of 104 or 110 like which were there in America. Even Sweden also, many advances are there. Even a road is laid through seawater. Number of even leaning tower of this number of models are there. So the engineering strength is quite high in not only India but also the state of Andhra Pradesh. So we should take up the challenges, and the solution can be obtained by interaction with the experts during the seminars or during workshops, etc. And the workshop proposed by the engineers of this area, this is really welcome, and we are happy to associate with him from IGS Kakinada chapter. And thank you all.
Thank you, sir. I started my PhD work almost 13 years back, and I am very happy that I am going to receive my PhD under the Vice Chancellorship of Dr. Prasad Raj garu. I am very happy for that. Now, our Center Secretary, Engineer Durga Prasad, has made a book on building construction checklist, and I request Dr. Prasad Raj garu to present this. ఎగ్జిబిషన్ కండక్ట్ చేసినప్పుడు పబ్లిక్ జరిగి ఇదే బుక్ ని మళ్ళీ ఒకసారి ఇక్కడ ప్రజెంట్ చేస్తున్నాం. చీఫ్ గెస్ట్ సార్, ఇందాక డాక్టర్ ప్రసాద్ రాజు గారు ప్రాజెక్ట్ రిపోర్ట్ 2013లో తయారు చేశామండి. అప్పటి నుండి దాన్ని ఇంప్లిమెంట్ చేయడానికి ఫైనాన్షియల్ కన్స్ట్రెయింట్స్ ఉండడం వలన అప్పుడున్న వైస్ ఛాన్సలర్స్ ఆ డబ్బు పెడితే ఇంకో 2 బిల్డింగ్లు వస్తాయి, డ్రైనేజ్కి అంత ఖర్చు పెట్టడం ఎందుకు అని చెప్పి ఎవరికాళ్ళు వెనకడిగేశారు. కానీ సార్ వైస్ ఛాన్సలర్ అయిన వెంటనే తీసుకున్న ఫస్ట్ డెసిషన్, మనకి డ్రైనేజ్ ప్రాపర్గా లేకపోతే ఎప్పుడు నీళ్ళలో మునిగి ఉంటే వర్షాకాలంలో దానివల్ల వచ్చే ఇబ్బందిని ఆయన సివిల్ ఇంజనీర్గా ఆయనకి దాని పూర్తిగా దాని ఇంపార్టెన్స్ తెలుసు కాబట్టి ఫస్ట్ ఎప్పుడు చేశారు. దానివల్ల నెక్స్ట్ రైనీ సీజన్కి మనం పేపర్లో ఇక్కడ జేఎన్టీయూ మునిగిపోయింది ఇలాంటి వార్తలు చూసే అవకాశం లేదు. ఎందుకంటే ఇది డ్రైనేజీకి దాదాపు 8 కోట్లు 9 కోట్లు ఖర్చు అవుతుంది అంటే ఆశ్చర్యం వేస్తుంది. కానీ ఇక్కడ పంపింగ్ అనేది కంపల్సరీగా అవసరం అవుతుంది. దానివల్ల మధ్యలో సంప్స్ కట్టడం వాటి వల్ల కాస్ట్ అబ్నార్మల్ గా అవుతుంది. దానికి తోడు సిసి రోడ్ కూడా చేసి జరిగింది. వీఆర్ హైలీ థ్యాంక్ఫుల్ టు హిమ్.
నరసింహారావు గారు. రావచ్చు ఖచ్చితంగా రాగలరు. It's the time for a vote of thanks. I would like to thank the chapter. I thank University Administration, the Senate Hall for organizing this seminar. I would like to thank all ACCA members, LSIC members, media partners, all the members who have attended for this excellent event I would like to thank Dr. Dayagar Garu and Jyotiraj Garu for supporting me in this program organization. I would like to thank my staff for helping me in this program organization. I would like to thank our members, LC members, Ramakrishna Garu, Srihar Garu for their supporting in this program organization. I thank in person all the who have directly and indirectly supported me in this program organization. Now we will start the technical session. Thank you all.
Now I request Dr. Ramakrishna Reddy Garu to deliver his lecture on soil structure interaction. Thank you. This soil structure interaction is a very interesting subject and action. Though the structure cost may increase, particularly foundation cost may increase slightly by adopting this soil structure interaction, but it is a necessity to have the durability of structure. For that, we need a little bit attention to know about the what is soil structure interaction, what are the inputs of it, and what is the advantage in doing that. All these things will be dealt by our beloved professor, Dr. Ramakrishna Reddy Garu. Now I request Dr. Ramakrishna Reddy Garu to take up the sessions. Thank you.
So respected Vice Chancellor of IIT Kakinada, Prasad Raju garu, President of Campus Civil Engineering Association, Kakinada, and also Geotechnical Society, Kakinada, and respected professors, lecturers, research scholars, and myself. They assume that the structure is fixed to the base and it is that, but in reality, the interaction between soil and structure is also there. The response of structure due to soil, and at the same time, the response of soil due to the forces acting on the structure. So this phenomena is known as soil structure interaction. And the recent IS 1893 report, that is so the general perception on natural hazards. All of you know that the planet Earth consists of land, water, and air. Without that, we cannot live also, right? Providing a cradle for existence of life. These three things. Earthquakes occur all of a sudden without any warning, and bulk of destruction takes place during the short earthquake. Phenomena they increase. And Haiti, Chile, Japan earthquakes in the month of 2 months only. And we are witnessing now Indonesia earthquake, Nepal earthquake very recently. So most of loss of life and property during an earthquake comes from total or partial collapse of man-made structures. Earthquake never kills people. Man-made structures which were not designed, they kill the people because of falling or collapse of it. So unfortunately, in India, not much awareness has been created among the minds of the people regarding the earthquake-resistant design, particularly the high-rise structures and important structures like school building, hospital building, reservoirs, dams, flyovers. We have to consider these aspects also. And awareness is to be created on the mechanism of earthquake. Do you know in Japan, even the school children, they know how to protect themselves during an earthquake. They go underneath a cable automatically. So that type of education is to be created among the people and public. And seminars of this kind, workshops of this kind. So the community living in earthquake-prone regions and coastal regions become alert and prepared against such disasters. And probably you must be knowing we are in zone 3, all of you know. I will show the different zones of India also. And particularly our AP state up to Visakhapatnam from Chennai, it is in zone 3. So what are the, just quickly I will go, natural hazards, earthquakes, or tornadoes, cyclones, and floods. Floods is another very important one. And fire and volcanoes will happen, and landslides will happen because during earthquakes, coastal storms and tsunamis. Tsunami is very dangerous natural hazard, and hurricanes. USA and other countries they are facing these hurricanes. So loss of human life in disasters. Look at here. Earthquake you can see. Whenever an earthquake magnitude more than 6 comes, so many people will die because so many structures were not designed against earthquake forces. And of course, this is due to floods, so like that, volcanoes and other. This is the percentage of loss of human life. And similarly, number of disasters, of course, from 1998 to 2017 are collected. And again, here also you can see because of floods, so much, and this is because of earthquake like this. These disasters, what we are facing, progress of, and it destroys the heart and fruits. And in fact, with a lot of dedication and with most of the standards, we construct some buildings or reservoirs or flyovers. But during an earthquake, nobody can stop. If the intensity is more, so heart and fruits and our painstaking development efforts and pushing our states and nations back by several years. Example is Bhuj in Gujarat. I will explain that also. Therefore, civilization exists and prospered mainly along the coastal regions. If you look at the most of the civilization, is developed only in coastal regions. India, Calcutta, Chennai, or Mumbai, whatever. Similarly, California, New York, Japan, most of the important cities in the world, they developed only in the coastal regions. And India is also vulnerable for increasing phenomena of natural hazards in future, particularly cyclones, earthquakes, and tsunamis. Upada, for example, very. So whenever a cyclone comes, we are witnessing so much of damage to the coastal areas. Now, the estimate of disaster-prone areas in India, 58.6 earthquakes prone to, that is the area, 12% floods, 68% drought, And the total coastline of Indian subcontinent is about 7,520 kilometers, entire India. And East Coast belt itself is 3,480, and the entire AP has a coastline of 974 kilometers. So recent occurrence of these hazards along the East Coast. Now what I have to do now? State of art of disasters. One has to understand remote sensing and GIS application. This is very important. Only through satellite imagery only we can understand about all the things. World markets, now they need retrofit or repairs. That is the first area for civil engineers nowadays. And awareness and reach the doorsteps of the people and the society. And workshops and seminars will definitely bring the stakeholders together and help in minimizing the loss of. We cannot stop the natural hazards, but we can minimize the loss when they occur. So mitigation measures and disaster management, of course, administration, district collectors and others, they have to take care. Just I will explain about in Atlas it is available. Earth is like approximately like a sphere, and internal core 3000 degrees centigrade. Inside the Earth, in inner core 3000 degrees centigrade. And next outer core is also there, 4500 centigrade. Then mantle, another 2000 degrees centigrade. So what happens? Slowly, the hot airs, they try to come out. Do you know the age of Earth? Just like you and me, having 70 years or 80 years or 90 years age, Earth is also having its age. It was already established. The age of Earth is almost 4,000 million years. And already 2,000 million years have completed. Half of the age of Earth is completed. And whatever you see, the mountains or the hilly regions or waters, all the things, they are only in the crust part. So we are all living on all these waters, all the things. And inner part is core mantle like. Do you know the weight of Earth? 5.5 into 10 to the power 21 tons. And the average basic gravity is about 5.5. Look at here. This is what I told you. So this is inner core, outer core, mantle, like this. Total diameter of Earth approximately 12,700 kilometers. Right? And another important point you must be knowing, because it is revolving, the diameter is increasing and north-south coast they are decreasing. So that's why all these melting of ice and all these things are occurring. So plate tectonic theory, this is very important. This is the reason for earthquakes and tsunamis. Plate tectonic means the earth has split into a number of plates. Number of plates, I will show you. And it's a fact also. You can see it in Atlas also. Therefore, this plate tectonic theory explains several aspects of earthquake occurrences. And this theory assumes that outshell can be divided into a number of rigid plates. The crust part, it has divided a number of plates. I will show you that also. 225 million years ago, the Earth was a single mass, which is known as Pangaea. Then 220 million years ago, it has become it split into two parts, that is the Pangaea and Gondwana and Laurasia. Later this one. And present day configuration is like the South and Europe, South America, North America, like that. So in future, the Earth will go on changing because of it is splitting. So the red shows the earthquake prone regions. So look at here, Himalayas, for example, and particularly California and South Chile and all the things earthquake has come. And you get on all the things that are prone to at the rate of few centimeters. So Indian plate has struck the Eurasian plate. So this is plate tectonic. You can major plates are 8 and minor plates are also there. And you can see this is Pacific ring, very dangerous plate. And so our India is the Indo-Austral plate, and this is Eurasian plate. This plate is going underneath Eurasian plate. That's why Himalayas have formed. Right? Therefore, Indonesia and so many earthquakes are coming here. And here Japan and China, they are also, and here it is South America, North America, Chile, earthquake, California. You are hearing in newspapers. So of course, this is how earthquake comes. Normally, earthquake focus will be about 30 to 40 kilometers below surface, and seismic waves travel. So that's why I have taken the soil structure traction. First, these seismic waves they struck the foundation. Then it when reach the ground, then the earthquake interaction in particular, it is very important when you design against the earthquakes or lateral forces, wind or something. So this is in fact the epicenter magnitude and also the source. Now here the principle of modes of failure normally the shear wall or any wall or even a frame, for example, three types of modes. One is sliding, all of you know, due to friction, and the next is rocking. Rocking means it rocks like this, about x-axis or z-axis. Bending. So this is a wall can bend up. Then normally which elements of the structure will be designed for lateral loads, wind or earthquake. So they are because suppose the wind direction is like this, therefore the slab and also the foundation and the shear walls. That's why shear walls are parallel to the direction of the earthquake force or wind force. And this is about earthquake philosophy. And in earthquake also, so slight means up to 4.9, and many times we are facing minor earthquakes only. Recently in Ongole, Vijayawada also got 3 or something like this, so number of times. And the moderate earthquake 5.5 to 6.9, great earthquake 7 to 7.9. India has faced a number of great earthquakes, particularly in North India, and very great above 8. These are the IS codes related to particular seismic zones. IS 1893, latest code 2016, 4326, and 13827, and 13920. Very very important code for structural engineers. It explains about the ductility, effect, and IS 1395, that is repairs and standard. Now, in fact, we have one research center at Gudlavalleru. By taking satellite imageries from NASA, from IRSA, Hyderabad, we have developed some maps for the Krishna district and also Guntur district. So this is at that time this was announced as Amaravati, that is our capital area at the time. Then we have studied the almost 3 to 4 magnitude number of times that it occurred here. Some minor cracks are also there. Cracks are also. Of course, throughout India, cracks are there, and majority of cracks are in northern India. And also there is one important crack from Maharashtra to Ongole. So that's why many minor earthquakes have occurred in this region. In fact, I made a research survey for Hyderabad city. That also I will show you. So this is the understand the zone, seismic zones. So complete northern Himalaya range, four zone or 5 zone, very severe zone, and blue indicates zone 2, and particularly our AP is zone 3. So like I said already, in IS code, these maps are available, and you have to design the structures according to the zone units the structure is located. Now coming to the impact, I'm sorry. If any architects are there, I'm just I say sorry to explain this, but it is a fact. See, you should not design buildings like this. Then what will happen? When going to upper stories, cancers, projections will be there, and particularly for lateral loads, these type of structures are vulnerable. Then you do like this. Similarly, you cannot do like this or like this. Suppose if we have uh, a joint here, look at here. Make a joint completely. Therefore, it should be a rectangle at any point of time. Otherwise, eccentricities will come into picture, and due to eccentricity, movements will come into picture. Therefore, the structure may subject to different forces. So here also you can make a joint. These are all available in literature. Same thing. So if you provide a balcony with openings, it is also prone to not a collapse or failure during lateral loads, but during earthquakes. Now I come directly for soil structure interaction. So structure failures were not considering SS effect. Which are not designed for soil structure interaction. That also. Then I will take up a case study of Hyderabad. So coming to the soil structure interaction, there is a very important relation between structural engineer and geotechnical engineer. All of you know. Without them, you cannot design any structure. So normally, structural engineer is bothered about the structural configuration, allowable bearing capacity, and its centric nature, and also the foundation. That's what a structural engineer normally does. Coming to geotechnical engineering, he will focus on inherent soil characteristics like C value, phi value, and NC, NQ, N gamma, their bearing capacity constants, like that, right? And recommending the type of foundation, whether it is isolated or raft or pile. So that is the almost duty of the structure geotechnical. But here the dynamic relationship where the response of soil influences the motion of structure. So it is due to vertical loads or due to lateral loads. So this relation is always it exists. Soil influences the motion of structure, and the response of structure influences the motion of the soil. This is very important concept. That is what is called the soil structure interaction. This is the definition of soil structure interaction. Suppose due to lateral load, soil will move, and the effect is on the structure also. Due to wind, the structure will move, and the effect is on soil also. So that's why soil structure interaction effect is very, very important, and it made it compulsory in the recent course. So under static and dynamic loading, the foundation and the structure behaves tandem together. And soil stiffness influences the effect of bending movement. All of you know, right? The bending movement and shear force are the structural limits also. Similarly, with the huge mass and stiffness of the structure, the fundamental time period for fixed base structure is less compared to the when you consider soil structure. So time period is very, very small, very, very small. When you consider soil structure interaction, what will happen? It time period is very, all of you know, it is almost elastic in nature. It gets coupled to the stiffness of the structure and changes in its elastic properties. What will happen during earthquake or during wind? The soil properties get changed. Similarly, mainly soil properties, particularly shear modulus, it gets changed because of poisonization and other parameters. Therefore, equivalent soil spring elements connected to the superstructure remain the most popular model in dynamic analysis. So nowadays, the researchers what they are doing in the form of springs, soil is attached to the structure, and then they do the analysis. Normally, what we are doing nowadays, we are receiving the structure is fixed to the base, and we are designing this, analyzing the structure. But if you consider this, then the real effect will be during lateral loads. It depends upon the characteristics of ground motion or wind, the surrounding soil, and the structure itself. The dynamic response of the structure is supported on soil induced in the system to radiation. Of course, damping will reduce the deflection. Soil is having more damping value when compared to the structure. Structure is almost 5% damping. Yes. So this is of course all of you know why ductility factor is very very important in designing the structures. You take a brittle material, for example, brick or concrete, only concrete. Then what will happen? Even the apply some force, the elongation at almost the minimum elongation phase. It will not deflect.
Right. So this is the stress strain curve. Right? So this is the force. Of course, force may be large, but the deflections are very less. In case of concrete or brick, which are nothing but brittle materials. But whereas if you take a steel rod, for example, when you test all of you know, so it takes a long time, lot of elongation will be there before it fails. Is it not? So it gives warning also. Brittle material never give warning, all of a sudden it fails. So that's why, particularly during lateral loads, earthquake or wind, you make the structure ductile in nature. It vibrates, but it will not collapse. If you don't maintain the joints, it is the ductile nature. IS 3920, it gives how to make a joint ductile. So this is very, very important factor for the design. You can see most of the apartment buildings, they make cellar floors, is it not? Cellar floors and flats will be there. So you see the difference. So this is cellar floor, open ground story. So in ground floor itself it displaces because the stiffness is less. Only columns will take. Therefore, the total displacement is a ground floor, and of course, depending upon the lateral force, they are also deflected. But whereas this is bare frame, so it slowly it increases like this. So you have to take care. But of course, we cannot avoid cellar floors or stilt floors, but we have to take care, particularly for lateral loads. So normally, high frequencies about 10 Hz and greater are dominant on rock or stiff soils. The frequency is more in case of frequency means the number of oscillations. Stiff means it oscillates more. Time period is less. And if it is on loose soil, what will happen? Displacements are very high and frequency is less. So below 5, so loose soil like that. And the behavior of foundation on the soil is modeled by foundation impedances. As I told you, very interesting phenomenon. We can adopt some springs and you can calculate by different equations presented by so many authors and the spring constant and other things, and you can make the structure mass spring dashboard system like that, and you can calculate the displacement, the shears, movements, everything. That is soil springs, horizontal and vertical motion also, and torsion also. I will show you some data. Now this is very interesting phenomenon figure. Look at here. So during earthquake, for example, this is the structure. First, the structure will shift. That is called free motion, field motion. Field itself will shift. So that is called UG, displacement of ground directly. And this is horizontal spring, which gives the horizontal displacement. And one another is rocking, another displacement, displacement due to rocking, and due to your structure, that is what is called distortion of the structure. So you can see the total displacement of the structure. So consider soil structure interaction. It is in reality it happens like this. But what we are doing, we are receiving the structure is fixed to the base. Of course, for that condition also some displacements will be there. But during earthquake or during wind, the displacements are very high, particularly loose soils. This is only single degree freedom system. If it is a multi-story building, multi-degree freedom system. So we skip this. Yes, IS 1893
structures resting on flexible soil, it is mandatory even for any field engineers because they have to follow IS codes. Now, structure failures for not considering, as I told you, quickly I will go different cases. And particularly during earthquake, fault rupture. Fault rupture during earthquake, some part of earth will lost crack, some kilometers. They have almost gone into the soil, disappeared in Alaska during earthquake. This is again good earthquake. A 5-story RC frame. How many stories you are looking? Only 4. What about 5th story? That is car parking, it has gone down. And we have witnessed a number of such happenings in Hyderabad and in Kakinada also, some other places. At Vijayawada, one water tank has fallen. So soil structure interaction has a lot of importance. This is bounding. Side by side, they construct buildings, violating the municipality rules or so during this is explained at least 2 to 3 minutes about this simple thing. Now during earthquake, one tie has broken. See, this tie, how much cost it will be? One tie, 6 mm or 8 mm rod, maybe 100 rupees. But because of this, the entire structure has collapsed. Therefore, due to lateral loads, the columns will act as beams. Is it not? Lateral load means they act as beams. Therefore, these ties, they become stirrups. Normally, we call in beams stirrups for flexor or shear. Now, columns will also take shear during lateral loads. Therefore, it has broken. What will happen? The spacing becomes double. So, like that, when it becomes double buckling has taken place. So, like that, the number of buildings in Ahmedabad they failed because of this. Right? Therefore, columns in the cellular floor in particular, we should be very careful. At least for every 10 centimeters, we have to provide stirrups. See, buckling of longitudinal columns because of buckling. This is what I told you, Andaman Nicobar Island. On one side, it has uplifted. Originally, the sea was here. It was uplifted. On the other side, there is a subsidence. I will show you that also. This is, of course, during Kashmir earthquake, sliding affected, falling of. This is, of course, Trans-Atlantic pipeline, very, very important. ONGC pipeline, for example. If the joint fail, what will happen? Lot of actions will take place. Therefore, original pipe is like that. It displays not only horizontally but also vertically. So, jointing the pipelines is also very, very important. This is the liquefaction effect, you can see, along the pipeline. Another important liquefaction, this happened in Niigata earthquake, Japan. You can observe due to liquefaction collapse. But some buildings are okay. There is no liquefaction. So partly. So this is the real photograph happened during 1964 earthquake. Again, same thing. Tilting of building due to liquefaction effect. In Vijayawada, one water tank has collapsed like this. Do you know this is Machilipatnam? During Indonesia earthquake, the complete Mangirapudi beach that is called Machilipatnam, a portion of beach was washed away. Diesel collector has taken care, of course, by vacating the people and all these things. Actually. So this is the Bangirapudi beach. During tsunami, it happened like this. And in future, I'm not sure, but there is every possibility that coastal region may be prone to tsunamis. Whenever a great earthquake comes, tsunamis are the second wave. Just I will show you.
Catastrophic tsunami rising out of the
You can see
Huge
that
waves sweeping
the
away
ferociousness
everything
of the
in its path.
tsunami.
A massive wall of water that rose as high as 30 feet, swallowing up parts of Japan.
During Japan earthquake 2011.
Throughout the seaside cities of the north, stunning devastation.
This is Nepal earthquake. Really, you can feel how the people felt the earthquake. You can see it is trembling. It is a real video they have taken. Luckily, I got internet. And some buildings are also. You can see how buildings are collapsing. And the people are afraid, and most of the officers they came onto the road. This is 7.9 or 8. It's only 30 seconds only. 30 seconds or maximum 45 seconds. Of course, this is also Japan, Japan earthquake. Okay, Japan earthquake. And the greatest disaster is the Gujarat earthquake in Gujarat. That is in 1993. Sorry, 2001. 2001. It was during earthquake, office records, everything they're falling. And this is the accelerogram. That is the, in fact, it is because of collision of two tectonic plates. Collision of tectonic plates. That also, so lot of disaster has taken place. Now you can see the flyover bridge, how it has collapsed. You can see it has fallen totally. Between the Philippine plate and Eurasian plate. Such videos are number of videos are with me, but due to lack of time. Now a case study on responsive structures concerning SSR. This is the theoretical study, and I also explained some equations which are available now to calculate the displacements, shears, and movements. Major metropolitan cities in the world have registered enormous growth in population. Most of the cities, people are migrating to cities. All of you know, right? And one of such cities earlier Hyderabad, now it is Vizag, Kakinada, like it. Unfortunately, in developing countries, not much awareness has been created in the minds of people about the importance of constructing earthquake-resistant or tsunami-resistant structures. The main objective of the study, our study, in fact, we did this study, is to ascertain various aspects of terrain associated with urban environment and to consider these aspects in dynamic analysis. Suppose you take Kakinada city. First, you have to make a survey and you have to develop a soil map where loose soils are there and where rocky soils are there, where gravelly soils are there, because so many types of soils make this. So first you have to develop a map, city map, that is called, which is also known as the microzoration. So that is very, very important because the structure which is designed in the rocky area is totally different but the similar structure as some soil. So that is very important. And in the present study, the terrain evaluation of high-tech city area particularly I have taken Jubilee Hills, Banjara Hills, that area we have taken. I will show you quickly. Now, just for your information, world population 6 billion by 2000 and 7.5 by 2015 and by 2030, 9 billion. That means the world population is increasing day by day. So we have to, and earlier 90 super cities were there. Now today, more than 180 in fact, because this data I collected 3 years back, almost 180 super cities are there in the world. So these are the different aspects occurred in the global aspects. For example, India, 1.8 lakh people died because in those days they never designed it like this. Like that, I can say Japan Kobe and Indonesia Sumatra earthquake and India, as you said, 7.9 and Indonesia Sumatra 9.4, 1.6 lakh people died. And due to tsunami in Chennai itself, Tamil Nadu, almost 9,000 people died. That we had already in newspaper. Of course, this I already explained. This is the area we have taken. This is Hyderabad city, right? And we have this is that area. All of you know Hussain Sagar in Hyderabad, Banjara area. So the study area is exposed to many minor and major magnitude up to 4.5, and it also consists of different types of soils, rocky area, loose soils, these valley fields. Unfortunately, we have identified that all of you know that near Banjara Hills area, there is a valley, and that valley was filled by different soils. And 3 years back, one building it has gone to the ground. It came into newspapers also. Therefore, different type of soils are there in Hyderabad. So above sea level, 488 to 637, almost 150 meters difference of heights are there in Hyderabad. The terrain itself is hilly region. Look at most of the locations. Yes. So we have landform analysis like location of valleys, ridges, all the things also located, and the lithology, type of rock or soil like that. Structures, this is important. Structures means earthquake, cracks and other things, major cracks, and groundwater. We have done this. So this is geomorphology map. You can see. That means you take some satellite survey and identify the type of soil where you are going to build a major dam or building. So this is the slope map of the city. So from top to the bottom, how to maintain the drainage system. Nowadays, what will happen? You start the drainage in one state, but again in another state it is above that. So that such problems will arise. Therefore, you have to take the slope map of the city or town. Yes. Now I just suppose I take a 7-story building. How to construct soil filtration? I have taken 21 meters by 12 meters size. So this is the plan. This is the section, of course. So one can design only for dead loads, live load and dead load like that. We can have the frame, and we get the by using Cornish method or stiffness method or using softwares, we can calculate the movements and shears, right? But how to consider the soil filter interaction? Other structure also elevated. That is what building is 21 meters height, whereas this overhead tank is only 12.75 meters. 2.5 liters capacity of water tank also we have. So this is the water tank. Normally we design 2.5 lakh and we provide bracings for lateral loads. Now what I have done, I made it single degree freedom. In fact, by philosophy, if it is in series, 1 by k is equivalent difference equal to 1 by k1 plus 1 by k2 plus 1 by k3 like that, you get the equivalent thickness. So I made it a single degree freedom. So like this, single degree freedom, I have calculated the stiffness of the structure only in this case. Normally, people design like this even for lateral loads. As I told you, equal to K1 equal to like total weight of the structure also we have calculated. Frequency also I calculate for single degree. This is what normally we do without considering the soil structure interaction. For example, I got the frequency 0.7 Hz. How these values will change. Now I am considering the soil structure interaction. Look at here, all of you. So this is water tank. I have already calculated the mass, top mass and also stiffness of the structure. Now the soil is represented by springs now. Horizontal spring to get horizontal displacement and rocking spring to get rocking displacement. And if torsionally there, torsionally no eccentricity. Here it becomes single degree freedom system and here it becomes a 3 degree because there are 3 springs. What is the degree of freedom? The number of possibility of displacement. So, how to analyze it? This F5 is the inertia force. All of you know what is inertia? Mass into acceleration. This is damping force. That is C into x dot. This K into x. That is restoring force due to structure. Therefore, this is the matrix formulation. All of you know, force equal to mass into acceleration. Similarly, damping equal to C into for the richest scholars and other faculty also, they know pretty well about this. And this is of course K into x is the restoring force matrix. So in matrix form, we can put mx double dot Cx plus Kx equal to external force, earthquake or wind, whatever. So you get the time period or frequency by putting 0 only. So time period you will get, you don't apply any external force. Any structure will have its own time period, its own frequencies, depending upon the stiffness and damping. So using this, you can calculate the time period. And keeping with the time period is very, very important, particularly for lateral loads. Now coming to the soil structure interaction. So soil response depends upon the soil properties like unit weight and the shear wave velocity. They are very, but shear wave velocity is very, very dangerous parameter. And normally in loose soils it is very less shear wave velocity, and in rock it is very high. For example, in black earth soil, its value is only 60 meters per second velocity. Whereas if you take a granite rock, 2500 meters per second. So this phenomenon is principally affected by the mechanism of energy exchange between soil and structure, as I told you earlier. So a soil structure interaction is modeled by introducing soil springs in horizontal and rocking loads. So shear modulus we can get like this. As I told you, if you have the soil profile of a particular area, you calculate X modulus. So like that, table 2 gives. So we have calculated for different soils, what are the shear modulus? We calculate. Suppose if it is granite, the shear modulus value is very high. For loose soils, it is very less. And now this is very important. Suppose if the foundation is isolated footing, rectangular, and this beta x we can obtain from this graph, and like that we calculated horizontal and rocking thickness. Now stiffness in case of piles, that is also translation, that is vertical displacement. these are the equations available. And of course, that is EP is the Young's modulus of pipe concrete, area of cross section, R is the radius of the pipe, and this FV1 and FV2 like that, they are normal coefficients. Already there are also available. Therefore, we can also calculate pile for pile foundations, the stiffness of the piles. So these are the coefficients that are available, normal coefficients. Depending upon Poisson's ratio and also E pile by G pile, that means Young's modulus by shear modulus value. So you can also pick up the appropriate value and we get the stiffness of piles also in horizontal mode and rotary mode. So these are the equations we can formulate. Now the 3x3 matrix. Therefore, I have formulated mass into, look at here, mass matrix. Right? This is acceleration. This is stiffness matrix. So mx double dot plus ks equal to 0, I get the frequencies. So I got the frequencies right. So this is a mathematical model for 7-story building. This is water tank, right? Not considering you say they are fixed at the base. Now this is multi-story building considering soil spring effect also, soil effect also. This is 7-degree freedom system, whereas this is a 9-degree freedom system because I have added 2 more spring soil springs, 9-degree freedom system. Similarly, water tank single when it is fixed at a single degree, here it is 3 degree. So you can see. So this red mark indicates not considering soil flux interaction and 9x9 matrix considering soil flux interaction. Both that we have compared. Stiffness matrix. Now this is the already available spectral curve depending upon the time period. Now I calculate the SA by G values from which I calculate the directly base. Using the free vibration analysis, I can calculate. So these are the results, of course, for building as well as water tank. I will show you the displacement. That is interesting. So story displacements, you can see, depending upon the story, they are the displacements for different soils. These are the different soils, depending it will not transfer. In loose soils, base shear differently. So generally it is seen that the displacement values increase with the decrease of soil thickness. So though this is an important point I would like to. The height of multi-story building is 21 meters, whereas the height of water tank is only 12 meters. Because of the stiffness is less, top heavy mass and flatter columns. And you build, therefore each floor will have a lot of stiffness. Because the stiffness is very interesting conclusion. It is also observed that there is a wide variation of decrease of displacements from loose soil to hard soil. So in loose soil, the structure as well as the water tank, the displacements are very high. So general conclusions finally, in spite of many scientific and technological advancements during past 100 years, the threat of natural disasters, particularly earthquakes and tsunamis and wind storms remain untamed. And history, geological evidences and experiences show that the rate of occurrence of these natural hazards will increase in future, well established already globally. And earthquake-prone society has to learn how to live in earthquake. I told you, Japanese people, they know how to live in earthquakes. And make the society more safe against the seismic damage and construct buildings, particularly in coastal regions. And megacities, due to their sheer size, the complexity and being situated in the high seismic regions, for example, Mumbai, Ahmedabad, and New Delhi, they are seismic regions. Therefore, unless we take care, we don't know what will happen in future. So earthquake engineers have an important role to play in seismic disaster mitigation, and earthquake engineers are nothing but civil engineers. These are some of the, I told you, water type before earthquake, after earthquake, retrofitting methods. Retrofitting methods, these are all. Okay, thank you very much. I have taken a lot of time. If any questions are there, I am ready to answer. Yes.
Sir.
Yes. No, not floating, sir. It's not floating. No, due to earthquake, what happened? Earthquake means it trembles. Trembles. So one plate has gone down. Six tectonic plates. Another plate has, therefore, the entire Andaman Nicobar. On western side, it came up. On eastern side, it has come up. That's a real photograph.
Sir, Dr. Reddy garu is kind enough to interact with all engineers. We can make interactive session at times. Thank you. Thank you very much, sir. Sir, the syrup has opened. Why it is opened? Because they have not made that inclination to 135 degrees, the stirrup angle. I am repeatedly in majority of the seminars, I am repeatedly saying that our site engineers should be very getting the stirrups. It costs nothing more. It's only a small engineers to train your site engineers to have the stirrups bent to 135 degrees without any hesitation. What happens with that? If the stirrup is intact, that bend will not take, the care is to be taken. Thank you. Now it is the time to present the post-tensioning methods and techniques by Crux engineers. Actually, post-tensioning for buildings is relatively new. But in Kakinada, the first post-tensioned building is Apollo Hospital, Samudra, previously that is Samudra Apollo, which was built after almost 25 years ago. From then, the post-tensioning techniques are available, but nowadays it is very popular, and the Crux people have done almost about more than 100 projects of mine in and around Andhra Pradesh, and majority of our other civil engineers and consultants are also utilizing the services of Crux. Now I request Sri Venkat of Crux Pre-Stressing to give a lecture on their product and about the post-tensioning techniques.
Good afternoon, everybody. It's a privilege to me representing Crux Pre-Stressing Systems Private Limited. This is established in 2005 by a group of professionals, Mr. Suresh Reddy as a managing director and Mr. Shekhar as executive director. This is our new office, new corporate office. Recently, we shifted in Hyderabad, Kajagoda area. In compression, relatively weak in tension. There are two methods to overcome this problem. One is embedding another material to the concrete, which is very strong in tension, called as reinforcement. Another method is a pre-stressing. Pre-stressing is a method of reinforcing the concrete by introducing pre-compressive stresses into the concrete to high strength steel strands called as tendon. And usually there is some confusion, not to the professionals, in the terminologies. What is pre-tensioning, post-tensioning, pre-stressing? The pre-stressing is a method of inducing pre-compressive forces to the concrete, but with the high tensile steel, and whereas post-tensioning is a method of pre-stressing the structural elements after concreting, whereas post-tensioning is a method of pre-stressing before the concrete of its tube strength and being and tendon is laid in the parabolic profile. This is a typical being when we are applying the axial pretensioning to the tendon, because the tendon is in parabolic nature, it tries to come straight, but it is embedded with it will not happen, and it is pre-compressive forces to the structural element. When we are applying axial pretensioning, because of low profile, the load is lifted from low point vertically to high point in downward direction. In post-tensioning system, there are two methods: the bonded post-tensioning system and another method, unbonded post-tensioning system. Our organization is worked on bonded post-tensioning system. In bonded post-tensioning system, the pre-stressing rate completely bonded with concrete through grout, whereas in unbonded system, the pre-stressing reinforcement is not bonded with concrete. And in bonded system, the tendons are not free to move with respect of concrete, whereas in unbonded system, the post-tensioning tendons are permanently free to move related with concrete between the anchorages. The merits of bonded system over unbonded system. The bonded system critically not depends on an anchorage after grouting is done, whereas in unbonded system, the anchorages fails in unbonded. If there is any chance, there is a chance of failuring the wedges, that is the end anchorage, it damage we cannot find. Whereas in bonded system, it is completely grouted with concrete. Even if fails the end anchorage, there is not a problem to the structure. Even accidentally any cutting in the tendons. Let us say a new toilet when you are introducing, there is core cutting happen. Maybe there is a chance of cutting the tendon also. Even cut the tendon also, there is not stresses in that structure. Completely bonded with high ultimate strength, and this system, bonded system, has high resistance against fire. And it's one of the project we experienced in Hyderabad for pharmaceutical company. And usually we design the structure for 2 hours fire rating. The structure is exposed to fire for more than 5 hours. At the time of retrofitting, we expose the tendon and we cut the tendon, we tested it. And that because it's completely grouted to the concrete, the strand property did not change at the time. So it has more fire resistance. If it is an unbonded system, it is not bonded with concrete, it exposed to the fire and it is for the structure. And this and the applications, there are many applications in the bonded system which can be applied for all type of commercial buildings, residential buildings, industrial buildings, and institutional buildings. And another way is when you are going for the transfer beams and transfer structures, we can go bonded post-tensioning system. And many uses like bridges, water tanks, large silos, exhibit GISs, everything we can do in bonded post-tensioning system. These are the materials used in the bonded post-tensioning system, that is strand, tendon, the strand and tendon. Usually strands are available in 0.5 inches and 0.6 inches in diameter. The strand is made up of 7 wires bundled in a strand form. And the tendon is types of tendons. And this one is a multi-strand tendon, higher strands and higher loading conditions. We are going for multi-strand tendon. And this is a rounded duct, what we are using for the tendon. This is the monostrand stressing machine, which is used stressing the post-tensioning design. The structural elements are thinner as compared to the conventional system, which gives more head clearance to the structure and also neat and simple. Let us say if it is spans higher than the 10 meters, we have the beam slab system in major beams, secondary beams, and whereas if it is a go for that centering, reinforcing everything, it will take a time. Whereas if, for the such as spans, we can go for a flat slab system. It may be flat plate system, maybe banded system. It is very simple and easy, and it is very neat simple. And speed of the construction. As we discussed earlier, the structural element thicknesses are very less, and consumption of reinforcement, consumption of concrete is less as compared to the conventional system, which leads increasing the speed of the construction. And also, when we're going for a bonded post-tensioning system, once we stress and grout, then like deflection vertically will happen in bonded post-tensioning system. And coming to saving of materials, in PT slabs, is proven that for the larger spans, it is proven to be economical because structural elements are lesser, simple in a system, which will reduce the cost of construction. For example, let we go for a 9 meters in span with a live load of 5 kN per meter square. Typically, we can reduce the PT concrete to 5 to 10%. And shuttering also we can reduce to 10 to 20% because there is no sides, no bottoms, simple in technique. So that is the reason we can reduce the formwork. And untensioned reinforcement. Untensioned because we have a post-tensioning reinforcement, then we can reduce the untensioned reinforcement to 6 to 70%. For the overall cost point of view, overall cost can reduce 5 to 15%. Done very comfortably and in safe in the structure. If the opening is lesser in size, because the tendons are usually 1.2 to 1.5 meters in spacing between the tendons, we can cut the openings. And if the openings are more, this is a typical layout, tendon and opening layout. Between the tendons, we can cut the slab and tendon by providing external support from the trucks. This is one of the great system, flat slab system with the drop panels. This building having a 12 meters by 13 meters in spans. For this one, we are designed with a 200 thickness and overall drop thickness of 500. And this is a banded beam system and one directional beam and other directional slab. In both directions, tendons we are stressing it. And up to 75 to 90 meters, we have done up to 90 meters for HEL 90 feet for HEL building at Bangalore at 40 feet height. And this is a typical example for transfer floor, which is done at Vizag for Abram project. For this building, this is a mixed development. First 3 floors are for the commercial purpose, and the next floors are for the residential purpose. We are floated at residential floor level, and which is done for 11. We are transferred the structure for 11 floors. And these are the some of the projects what we have done from the crux. This is a Novotel at Vijayawada, having 2 commercial floors for banquet purposes and 11 hotel floors. In this project, we have done transfer for 11 floors by using Verindil Gutter as transfer beam. And this is a Radisson Hotel at Vijayawada, and this is one of the upcoming project in Vizag, having two blocks. One is completely for IT, and another one is for hotel. Yeah, that we can finish. And this is a hotel floor. We are floating this structure for 20 floors. That other commercial projects there is no floating. These are some of the institutional buildings for the KL University. These are the some of the blocks what we have done in KL University. And these are some of the multiplexes we have done from the crux. In Vijayawada, these are the multiplex and Vijayawada train set. And this one is Centri at Vijayawada, CMR at Ellore. These are the multiplexes. Phoenix at Guntur, having a 12 by 13 meters in span. This is a Golden Mile at Hyderabad. This is a Malarati multiplex and Sensation. These are the 13 multiplex at Hyderabad. And these are the tallest building. This is a IT Park IT Park at Vijayawada, Hyderabad, 24 floors, and in this project also we have done 24 floor floating over the 20 meter span. The span is 20 meters by 20 meter. We have adopted grid beam system for the floating purpose. This is one of the highest building having a stepped down construction. It's also having 18 floors, and this is one of the another IT park. This is another IT park that we have done. This is another IT park. This is Mayur Tech Park at Vijayawada. This is now we are doing it. This is flat plate system by providing 50 mm sunken for the toilet purpose. This is also one of the projects already finished in Hyderabad. Flat plate system is adapted for residential purpose by providing 50 mm sunken for toilet. This is a mixed development to our commercial and residential 12 floors self-floated. This is now we are doing 45-story building for Vasavi Atlantis project having 8 blocks with 45 stories floating. Above floors they are adopted forward technology. We are calling as a Maiwan walls. In this system we are floated the 45 floors at first floor level by using flat plate as a transfer slab. And this is another project, Green Space Marvel. In this one also 45 floors we are floating at first floor level with flat plate system as transfer floor. And this one already completed two projects with the 22 floors for DSR group. Where in this project 22 floors are we floated at first floor level. These are the some of the transfer slabs, the laying, tendon laying. In this we are using multi-strand tendon in both directions. This is another project by using this is already we discussed. This is Abraham Touchstone at Vizag. Thank you for giving this opportunity in front of respective engineers. Thank you very much.
Thank you very much, Venkat garu, for your elaborate. Any doubts are there? During lunch, you can have interactive lunch. There you can clarify your doubt. Because of shortage of time, we are utilizing the lunch time as interactive session. Now, I request Sri L. Subramanian garu to deliver his.
Combined with railways also. So both have to work in tandem to get the problem addressed properly. Right? Now, for this, I will do one thing. I will, this is a change. Everybody talks about change nowadays. What is change? C is for conviction, H is for honesty, A is for alignment, N is for the end of the show. You have to have this in your mind and you want to adapt a new system like what has been told by my previous speaker regarding adaptability of post-tensioning slabs in Karnataka. They are really advantageous. And now I say those who change after the change just will survive. Just survive. But those who change with the change will succeed. You understand the difference there. The third one is those who can cause change will lead. Now I think Sundaragar has been in the third category where he is trying to lead lead all the engineering fraternity and consultant fraternity to go into the right direction with his good services. And now I will not get into the total details of foundation. The foundation which I am going to talk about it falls foundations. Now get into too much of that and just pass because of time. Now I'll talk about this only. These piles. And the genesis, when the pile foundation started, is as early as in 1740. That is the genesis of the pile foundation. So then as the age passed, so many things have been developed and in the right technique now, like pile and to pile the pile, bigger piles. And
Yeah, so the last one is adaptability of the pile foundation is a site and a structure specific. So whatever you just cannot jump to a conclusion saying that it requires piles. No, it is not that. See, you cannot tie a horse and a donkey together. That is what I'm saying. A donkey has to be dealt like a donkey, and a horse has to be like a horse. And this one, where do we adapt this pile foundation? Low bearing capacity, non-availability of proper bearing stratum at shallow depths, heavy loads. And the third one, you see, if the results of soil investigation show the shallow soil is unstable and weak, or if the magnitude of the estimated settlement is not acceptable. See, this is the most important point. Everybody doesn't pay much attention. It becomes a no man's baby. No, soil investigation. It has to be done. You have to thoroughly get into it, thoroughly introspect into the various nuances of soil engineering and decide what to do and what not to do. Just like that, don't adopt, as somebody is saying. Don't do that. That is what I am saying. And no, generally, pile foundations, we are adopting for a very major bridges, and the bridges, the very long span bridges there. So these are the types of pile, and this is the thing. Actually, at one place, they have used 1.7 meter dia pile. Another place which we are going to start, it is 1.5 meter dia pile. Depending upon the things we consider, but when it comes to the bridges, the question of discharge, cover depth, all those things will come into picture. What is the grip length of that pile? Actually, when the soil, what is the scour in the sense is that suppose something happens, up to what level the soil will erode? Will just flow away from the structure. Till then we decide. So that is a balance depth, what we call it, we go for a grip, that is called. So what all those things that friction developed at that level only, it is considered in that design. Definitely the friction will be more because soil will never get eroded. It's only a theoretical point, covering and all those. But we are having on positive side, so we don't consider that. Not always they work well. Something you have to always don't get into that. Yeah, this is another type of and this is another thing. What are the loads the piles are subjected to? One is the vertical, another is moment. Moment will be very predominant in the high volume, high substructures, where the moment will be very heavy on that. And the horizontal force, it is nothing but due to the water current as well as the earthquake. Those two forces will be considered in that. And these are the group of piles, and these piles, these are the pile system we use for abutments, where the moment is predominant due to the earth force behind the abutment. It has to be translated into the ground. That is why we are like a stay where for a current pole you will go for a stay thing, like that. So this is that, and this is a typical pile foundation system everybody knows that. And what are the load carrying mechanism? It's an end bearing cum friction pile, as I already told you. A pure friction pile, we don't practice this. Pure friction piles we don't consider. We consider even end bearing as well as pure friction also. Yeah, this is that. And now I'm coming slowly getting into this. This is, field approach and a theoretical approach. A lot of difference is there in this. Theoretical approach, theoretical approach, before getting into the design. Theoretical approach in the sense, if your subsoil explanation is perfect, then we'll come to know at what level, what are the types of layers, how much load. Then you have to cross-check it again. Then go to the field, conduct a test called initial test. Conduct it and assess whether the pile is taking that much load as kind of theoretical. Definitely there will be a gross mismatch. I will show you that. Then if the subsoil investigation is improper, that's the underlying thing. And yeah, this is how we calculate the theoretical approach. Using the theoretical approach, of course, not so visible. Just I wanted to tell you how much effort will go into it to calculate the total load taken by the pipe. So this is depending upon the number of layers. See, these are the layers up to this is 51 meters. You just remember this value. 334 is the total vertical point. This figure you just mind it. It is 334 tons. Later on we'll come to that. So field approach again. Now this is important. See, I have designed as per the theoretical material available with me, and now I should ensure that the same are translated into the field. How do I do that? So we conduct an initial test. Initial load test. This is to obtain backfigure soil data. That is what I am saying. Backfigure soil data is whether what we have done in the sitting in the office is correct or not. So, and if suppose if I am getting very high strength than the theoretical approach, then I'll revise my designs. I'll revise my entire structural designs of the pipes. And to verify the structural soundness of it, and it results in economy also. If the pile which we design is taking more load than the theoretical approach, then it definitely results in an economical approach. So this negative skin friction will not get into this. Yeah, this is the bridge constructed during 1999, 2001. They completed the bridge, and it was done by Naviva Engineering Company. They completed the work in a record time, very record time. It was completed. And here the piles are driven, not driven. Board casting C2 pile. I'll just show you. Let it not be for the present delight or for the present use alone. Let it be such a work that our descendants will thank us forever. This is intentionally I kept this slide here because the bridge which you travel on NM is a flawless bridge, and it had connected. Otherwise, we were traveling in the punts that time, right? Even today, there is no problem. Whereas on contemporary, near Nasapuram and bridge is there, you will have a roller coaster ride because the Nasa priest is there. It's a balancer cantilever structure. Here the priestess is lost totally, and now all the handrails will be like this. You see the profile of the handrails, it will be like a sign there, right? Unfortunately, it will not get into the fourth quadrant. If it gets into fourth quadrant, the bridge is gone. Yeah, this is between I and Godavari here, very nearby, 27 kilometers from here, and this is the alignment. And I will show you one more thing interesting. I had worked in the investigation of this bridge earlier. So we thinking that we had used all those compass, LEDs, rusted theodolites, leveling instruments, plane table, and all those things. We thought whatever we had planned is a crossing. So this is the normal crossing. We originally, this is the plan given by us, thinking that is the normal crossing, right? When the work was awarded, Naviva Engineering came into picture. They used all this electronic throttle station and everything. They used the same peg marking, and we could get a difference of 120 meters. Imagine. So, had we constructed the bridge in our own alignment, we would have in construction of this Q bridge than a normal. So, this is the and selection of foundations where selection of foundation is a very important thing, and nowadays nobody is going for wells. everybody is going for pile formation. And again, as I said earlier, it's a site dependent and also structure dependent also, right? And here, we had a very bad experience of well foundations at two of the major bridges here only. One well shifted around 2.5 meters away from the center line. Ultimately, it was abandoned. So we have gone for piles all around the well, taken a pile cap, and projected our and kept our substructure exactly in the physical center of the alignment. So well foundations are nowadays they have become obsolete. Still I don't know, railways are using that because their Kotpalli railway line, they are using well foundations up to -52. Imagine the effort they have to put. And I don't know how they control tilt and shift of that well. And this, as I said earlier, okay, this is the structure. Now, this telling you this is the pile gap, this is the ground level, and you see -14.3 is founding level is 43. Roughly, it is around 42 meters. We have gone for the depth at various. I mean, depending upon the because along the length of the bridge, soil profile is changing. So depending upon the so they conducted soil investigation at each and every location. Each and every peer location, we got the values. Right? And this is a typical bore chart gave to us. And you see it is almost all the wells are founded at this level, where N value is more than 50. It's a hard stratum we have found. Right? And this is what I was talking about. There are two types of tests. One is direct loading, another is a react loading. You can apply reaction because see 2.5 times you see this 700 tons, around test load of 1400 tons we have to create. It's humanly impossible to keep 1400 tons on a pipe. So we create a all-round pipe for a reaction loading. So very simple, it's Newton's third law. Whenever you pull up, actually you use in the dots, it pulls up. Then it will be restrained on the four sides. Automatically the reaction comes to the pipe. That is nothing, very simple thing. And I think the settlement here, one important thing is it is elastic shortening of the pipe. Do you know concrete gets short when you use too much of load? Sometimes it bounces back and sometimes it has a plastic by designing the substructure as well as the superstructure where sufficient bearing thickness, allowance for the bearing thickness has to be given there. Otherwise, again the deck will be like this. You will have a roll cast deck. So this is the total settlement. Here is a corresponding settlement at 12 tons. It's a 1370. A safe load, it is only 940 tons, which is more than the design load. Yeah. See, this is one important, initial load testing. And this is a 1.7 meter dia pipe. And interestingly, you see this angular, the pile is here. The casing is here. There is a gap between the pile and the casing. Why? Because we are simulating the scour. In case of scouring, if everything is washed off, the pile should not take any load by virtue of its friction with the existing soil. So we have gone a 12 mm thick casing up to the maximum cover level and then applied the loads. That is replicating the exact my design. So, and you see, imagine these two, those things, jars. You have to get a very heavy duty cranes to place them there. Very, very meticulous. Two. No, one pile only. One pile. Yeah. This is a rig first time imported from Germany by the contractors. They used this rig for 1.7 meter dia. Yeah, this is, I think everybody should understand how a pile will be placed in a water body. In a river, how do you place a pile? You will have no, because there the no. So whenever a water depth of 8 to 10 meters is there, how do you place your pile? Then this is the arrangement, this is a barge, and these are the legs, and it can take up to 300 tons of the pile. So it will go to the location, and all these legs, see, it has gone to the position, and all these legs will be lowered, so it will touch the bed, and it will be, everything will be locked. And using your ETS, the locations will be finalized for all the pipes, and the rig, earlier I have shown you, this is the rig mounted on the barge. It will go to the place and start drilling. And with all this, this is how these casings are being driven inside the, subsoil, in the underground. And this is for driving the, your liner. Liner is another thing. Now they have used gigantic liner. But recently, we have submitted designs for bridge at Narsapuram. And the span is around 42 meters. Why 40 and why not 50? Why 42? Because it has inland waterways requirement. They wanted minimum 42 meters. So we have followed 42. If you go beyond 42, casting beds and launching of the decks will be very difficult. You need to have, because it is as per the Morth design, will have 12.9 meters outer to outer deck. So you will have 5 gutters. 5 gutters have to be cast on the approach and transfer it onto the launch it onto the piers. So the length restriction will be there. So we have reduced the length to 42 meters only. There, the lining, question of lining came. As per the latest IRC code, whenever there is a proximity, you are in the proximity of saline atmosphere, saline water, it's a backwater effect is there from Mantravedi. Here, of course, in Annam, there is a backwater effect. So there you have to provide a casing up to the full depth. Then what happens to the friction? No, it's not zero. Actually, the code is silent on that. Code never said when the pile has to be sunken with a casing up to the full depth. You see, consider this friction and that friction, not that. But we have used a friction factor of 0.25 as per the code. So that, let us not get into that. We have designed it. These are approved also. Next slide. Yeah, this is the lowering of the cage. It is around 37 tons each. See 80 numbers, 85 numbers of 32 mm diameter pipe. And this is on a semi-concreting is in progress. And this is another thing, routine test. Routine test is that 2% of working piles, you have to conduct tests on the 2% of the working piles. Working piles is the water. Then again we have compared same reaction loading, and then we have conducted the test. The place where the test was conducted, the water depth is 8.5 horizontal, lateral load testing of the pile. The pile is subjected to lateral loads. As I said, lateral loads will come into picture when the seismic loads are taken into account. And these are the things. And now I'll just get back to you because from years. For that, anybody who happens to visit a site like this, right, and taking a site and keeping a thick plate, they cut the plate into the chain shape and they used it. Yeah, these are the parties and these are coming. And this is called, stitching. When the two gutters are launched, the gap between is called a stitch concrete. That will be placed without any, centering also, they will be floating. They will not keep any centering from bottom. That will be done from the top only. Yeah, this is completed, bearing. Yeah, this is a gallery. You can walk through. Even now also you can walk through. For inspection of bearings, you have to inspect the bearings timely. Whether they are in a correct position or any decay is there or things like that. All are they have used all part PTFE bearings. This is a completed one, and this is one. So now I will go to a failure story. Now there we tasted the success there. Then we are going for the failure thing. See, this is the alignment which we have talked all the way now. Now another bridge we have started constructing. No, we are not constructed. It is still under construction. Yeah, this is the place we have planned another bridge. There also we have gone for pile foundation. The proposal was in 2007. Of spans 12 lengths of 32.23, foundation 6 mm of 1.3 diameter, 33 meters. Here, just see this 33 meter deep. And piles with full MS casing. As I said, in a saline atmosphere, we need to go for a full depth excavation. Casing. And design load is small because 330 and it's a box type gutter, so loads manifested will be very less. So it is 250 tons. And load applied, reaction, everything is all at per theory. So now the engineering company, by the time they were doing that bridge, so we asked them to conduct the soil test here at the this place also. They conducted the initial load test and gave us 250 tons as a safe load. No, 250 tons. Just remember, 250 tons. And this is a soil, just for any, because so many people are here who are geotechnical engineers. See the N values there. 1, 2, 3, 4, no, this, I think, SPD value, 5, 7, 6, 7, and maximum is 15 or 45 at a depth of 42 meters. Right? 30, no, 46 is also there, 40, yeah, this 46 is there. We can curtail our file at this problem. But the designer had preferred to cut down the file at 32 meters. Here it is. So the prudence behind this is really today it is boggling us. The work is not completed. Rested at a very higher level. Where SPT, simple, don't forget about skin friction and bearing and all those, we'll not get into that. When the N value is very poor there, how could he rest his file there? Okay, that was done. And the followed is the history. Whatever has been done is a history. This is the load settlement curve given by that. And first thing, high-strain dynamic load test was conducted in 2009. They gave 424 tons. You see, around 5 to 6 times we had conducted the load testing, and each time it has given a different result. Right? Against 250 tons, which is with each 5 times. By the time he has completed all the pipes, but by the time we came to know that the pipes are not taking fully designed load, what to do? Then we started forensic studies. What happened, where it went wrong, and all. And the contract was terminated. Because the company is a very experienced British contractor. Was to know contractor. He came to the site, and again he was asked to conduct the test again. Why I am showing this articulation of this loading and all this, because never ever venture into pipes. DC, he is a so calculated, perfect contractor. He has given us the Kentledge calculations, what he is going to do and all those things in a schematic time. This is how he wants to place all the, say, blocks, concrete blocks, to for the loading. See, this is how we calculate it. Each layer, how much load is coming onto that, including all these things like a bucket. There will be there one is called a stool or bucket. It will be here, including that all whatever. Even if you stand, we have now taken your weight also. And see that one is that lowering of cage for that concrete. This is a casing. Another is a lowering of steel. And see the arrangement for the initial load test. See this. And these are the jogs. And you see the here. Somebody is asking how much load is taking. See this gauge reaching zero value and loop gauge, dial gauge, it started rotating like Vishnu Chakram. It started rotating like that. Even my friend is here. You are also here. That when we tested one test, there also it has gone totally just uncontrolled moving. So we all came out. Just by. Yeah, okay. See, the contractor will not be paid, but he has made so much of it. We did not pay him. He including 32 lakhs, right? The test was conducted. Yeah, this is the overall how we have. See, because earlier we had suffered the settlement to the pool outside subsoil, so he made all these things with the sand filling and etc., so that it did not settle even prior to applying loading. That's all right. Then he applied the loading. You know at what time, at what load it was failed? It's only 28.4 tons. It failed at 28.4 tons. There is 250. What was the result given by the contractor? That it is suffice 250, and the third one is it has settled without applying thing. Fourth one it has come to 179, and the fifth one has come. It is coming 28.4. So we had no clue why it is happening. And the system, now the present situation of the bridge is this. 2007, we are into 2022. 15 years had lapsed. 7 crores was spent on that, and it has, and forensic this thing, soil resistivity we have conducted. From Andhra University people have come there. And this is the soil profile we had matched. We wanted to know what is the soil available at what depths. Everything is good. Even this is good. And then again, we have gone for pile integrity test from Gujarat. Those people have come. We have conducted pile integrity test. All our piles are good. See, this is the pile integrity, and you should understand this. Wherever these ups are there, no, there can be a crack in the pipe. That is discontinuity. One thing, if at all, if you want to start construction of a pile, never stop the concreting in between. Complete the concreting in one go. Don't give any a gap. Even not even for lunch. So if such ups and downs are there, that indicates there is a discontinuity of the concrete. That may be the difference. And one more thing, soil intrusion. When soil lumps are intruded into the concrete, there also will get the same discontinuity. But we could not say overall our piles are safe from this. Only thing is they are not taking load. So present says piles are not taking load, and now soil behavior is thoroughly introspected into before actually grounding you are. And one thing, efficient structural design is not only order of the day. So what you have to do is a thorough designing of foundation soils. And see, actually, sir was telling both geotechnical engineering and structural engineering are wife and husband. No, you can never individually act. Suppose if you have totally independent of your wife, you can act independently, but definitely that will not happen. So both the things, we have to have a concentrated, effort and take the advice of the geotechnical engineer. So, soil behavior is unpredictable, right? Like many of us, right? And so be careful with what? Files. No, the next one. Files, it is not technical, both medical also. Be careful with files. Thank you. And this is another good thing. 85% of your financial success is due to not your technical know-how. It's only due to your personality and ability to communicate and negotiate and lead. Shockingly, only 15% is due to your technical knowledge. It is not told by me. It's a famous university, Carnegie Mellon University. Right? And with this, I conclude one presentation. If I am given time, another 10 minutes, I close it.
Will it be okay?
Will it be okay? Ah. No. Dayagar is asking something. Summarize, చెప్పండి. You want anything more? Huh? So no, I just then keep you in a lighter beam then. Okay.
So when are you constructing the superstructure then? We wanted to know when are you going to construct the superstructure?
When are you
going to construct the superstructure?
I will pitch bridge.
Where, I mean, anyway, you know that from your tests and all, your files have some problems.
Yeah, it will take more time. If I start telling you all those nonsense of, design and all those things, it will take much. Yeah, I'll keep you, I'll make you a little sit up. Then, let's see. No, I'll say that. Right. Come on. I think. Okay, just for the students, I think we are here. A small bit of advice to you. I think students are very much there, they're sitting backward. And jumping, they're called cliff riders. And yeah, this is whoever, I think we are all from Kakinada, and we know this bridge, Railcom Road Bridge across River Godavari at Rajamandri. We have been facing problems with this, and you are having a very bumpy ride on it. And I'm going to showcase what exactly the problem is. And there have been many attempts to address this problem, but it's of no use. This was constructed between 64 and 74. I think most of you have not born by that time. and constructed by both railways and actually railways have constructed the bridge. And the government of Andhra Pradesh asked us to we on the road on top of it. They allowed only farming of approaches only. So whatever is proper on the river Godavari, it was entirely built by railways only. And the maintenance part, that also this is that bottom is a precipitated steel structure. And according to the MOU concluded in 6/12/1982, the state government has not been paying it. So SCRC in 2009 had conducted, no, we had so many problems that cropped up, and SCRC Structural Engineering Center, Chennai, sir, our old student, Mr. Gandhi, we. So we had an extensive conducted this test by vibration analysis, and they gave the recommendations, which are of course not accepted by the railways. And this is a span arrangement. One is 45.72 and see 6 spans of 45.72, and over river it is 27 spans of 91 meters. You know why these small spans here and there? Because the bridge approach has to enter into the curve. So they have preferred the smaller spans, right? And we have major joints. There are crocodile joints at 35. That's on all pier locations, 35 numbers. And secondary joints, 432 numbers at 6.7 meters. So entire length, when you travel, you feel somebody is hitting you from the back. Every 6 meters one hit from the back. It will be like that. And how it can, I'll tell you. Say now the top upper deck is 210 mm thick slab, and the depth of the next slide I'll show you. Deep from here to here, depth is 12 meters. 12 meters. The depth. The top deck is RCC deck, and this is bottom is again rail deck.
Is that the composite or non-composite? That concrete deck?
Top one is a composite.
I mean, shear characters are there on top of that.
Yeah. That I'll show you. The deck is supported on a steel truss bit. Each slab is 6.7 meters because every secondary joint is 6.7 meters, and this is along the traffic direction. And the flow direction, we have two unsupported spans of 2.5 meters each. So 2.5, 2.5, then that also I'll show you. See, this actually, see the design beauty of it. It was left intentionally, it was not connected, it was left to cater to the everything. The bridge would have uplifted at the joints itself. So, the recurrence of vibrations inducing cracks, rendering the repair work. So we have tried number of solutions, and all these repair works were became redundant because suppose if you use a micro concrete, at least we need some curing time, isn't it, for settlement? Even when we lay the concrete and in the bottom deck one train goes, that's all gone. Micro fridges were formed in the concrete, and later on it all became useless. And you put night only, there is a time where there are no trains on the lower deck. But night, who will do it? Who will come for our rescue? And this is the deck, 12 meters high. This is a 2.5 meter slab. These slabs are 2. This 1.5 meter is footpath, and these dotted lines are secondary at every 6.7 meters. See, these are the 6.7 meters. See, every 6.7 meters you have that. And this is the crocodile joint placed over the piers only. That is about 91 meter span. And this is the instrumentation done scheme by SCRC. They're not of much relevance to you. Yeah. See, this is a cross gutter, transverse gutter. This gutter is in the flow direction. See, this is one transverse gutter, another transverse gutter is there, there is 6.7 meters. And these are the longitudinal gutters. Right? And these are the concrete slabs. You were asking about the
at 6.7 meters interval. That point I didn't understand.
yeah, that is what. See, in the truss itself, it has so many members. Between the vertical two members, the spacing is 6.7 meters.
Correct.
So directly we cut our slab there on. So,
No, no.
and one more thing.
No, okay. I mean, in the deck actually, at 6.7 meters interval, why they have put their joint there? They should have continuous deck. No?
No, that is what I am saying. See, there is a design approved by RDSO. Why you are asking? Instead, you can have a continuous slab instead of this thing.
No, I mean,
91 meters.
No, I have designed such kind of bridges. Even 120 meters I have done.
Okay.
But I never designed like this.
Yeah, maybe. This was the technology provided in 1964. 1964. It was designed, no, 1964 it was awarded. I think design and all things might have taken place even prior to that. 1960s. So, say this is the 2.5 meters, 2.5 meters, secondary joints are there. And this CC haunch is there, no? You are asking the shear connectors. We have the shear connector welded cross gutters over which the concrete has gone.
But that shear cutter is to the cross gutter, right?
No, even the longitudinal gutters also there.
Very good.
I think I am clear up to this. Yeah, this is a longitudinal gutter going along the traffic direction and meeting the transverse gutter. This is fixed, you see. I think this is fixed. At one end it is fixed. And the secondary joint. This is the culprit. When it comes to the other point of it, see, there is a gap. There is a gap. So, SARC observation is this is theoretical. You see. And another problem is the free vibration generated in the case of vehicle movement doesn't decay fast. That is the most culprit number one. It does not decay fast. So before it vehicle moves, actually the SARC people they have kept the two vehicles fully loaded. And whenever the train was passing in the lower deck, they were prior to our train, and yeah, this was a micro concrete done. Yeah. We cannot have used to get this because of the uncontrolled movement of the train wheel. They cannot stop the vehicles for our country. Yeah. See this. Yeah, the recommendation of the SRC is to weld a cross gutter at the unsupported wedge. You know, railways, so naturally it has gone to RPS. Means in permanent recreation, rail and power block has to be there. But rail and power block, they said they will give it only for 3 to 4 hours a day. What is the staging height you have to go? 12 meters height. And lift the gutter, weld it there. Suppose if it all, it always increase it. That's the human impossible. That's not that. But then we tried. Yeah, this is the joint is here. See, this is the cross gutter. Joint is here. Joint is not on the cross gutter. So this discontinuity is there, no? This one. That is causing it. So whenever there is vehicles are passing, they are moving like that. And when the vehicle passing coupled with the train movement, then the other way it is moving. And as a result, it is pushing up the secondary joint on top of it and slowly forming the humps on the secondary joints. Yeah, this was the solution. Actually, we had done. Wanted to put these blind plates and one top plate and all those things. It's all impractical. And one thing, yeah, this is that. even for 6.5 crores we have to spend. Yeah, after that, we had removed all the top layers of bitumen in 2015 Pushkaram.
For that, we are having small questionnaire. Distinguish between brittleness and ductility. What is the difference between brittleness and ductility? If no students are answering, any engineer can answer this. Sir, you are not allowed, sir. In what context generally we use this? Manikanta. Manikanta is
Mantala, sir. Soil mechanics student.
For which type of soil, the time period of the structure is more? Rocky soil or black cotton soil? Black cotton soil. What is the reason? Huh? Student.
I said student.
No, if no student responds, definitely Nageswara will get gift. That, no, I am waiting for students to answer. If nobody answers, then I ask Nageswara, who is that?
1 minute.
The answer is black cotton soil
Why? What is the reason?
because it resists the vibrations.
No, it resists the,
Vibrations.
how it resists the vibration? Yeah, I am repeating the question. For which type of soil, the time period of the structure is more? Rocky soil or black cotton soil? You said black cotton soil. It's correct. But what is the reason? Because the stiffness is less. You are from
Hydraulics. MTech hydraulics.
MTech Hydraulics. Please come. ఆయన ఇస్తారండి మీరు కూడా ఫోటోలో ఉన్నారు సార్. There are two structures. One is a 6-story building, 20 meters high. And second one is elevated water tank with top having heavy mass and slender staging. In which case the displacements are more due to lateral loads. Yeah. Huh? Elevated water tank. What is the reason? Top heavy weight. Please come. That is the purpose. introduce yourself.
My name is Rasmad. I am from Hyderabad.
You are forbidden. Please, sir. Please, sir. In which case, shear wave velocity is more loose soil or Moram type soil? Moram type soil. Why? No, sir. For everything, the reason is also to be explained, sir. ఇంకా మీరు రాకని కూడా పెట్టుకున్నారు. Shear wave velocity is more for more. Only one more question is there. Sir, please, sir. Please, sir. Please, sir. Due to lateral loads, that the bending moment values will increase in beams or in columns. Explain the reason.
In lateral load, the column acts like a beam. Bending will be more in the column.
Yeah, correct. Please come. Nowadays, actually, I generally in all my seminars or webinars, I used to explain columns as vertical beams. Now the columns are to be designed as vertical beams only. They are no longer compression members. Generally, we feel that columns are compression members, but practically columns are not compression members, but they are vertical beams.
My name is Chiranjeev. I am from soil mechanics. I'm the student.
Thank you, students, for your active participation. So, what we can come to a conclusion that the students who have attended here are not slept. Thank you all. And there are few certificates of new members. I request Samim Banu. Endowments V. Rajkumar. Chadaram Govi. Mallampalli Chaitanya Guru Subhash. Srinivasarao M. Srinivasarao M is a chief engineer, worked in Dubai for almost 20 years, and he came back to Kakinada and he started his profession as builder. We are heartily welcoming you, sir. Suresh Tota. Mata Venkat Suryanarayana. He is a retired superintendent engineer, worked in Kakinada Municipal Corporation for some period, and now he started his career as a consultant. And we heartily welcome you, sir. Kakarpatti Sri Swami Satish. Murali Krishna Naidu. Kadapudi Karna Kumar, Adarsh Engineering College. Thank you. Now the publications which we have shown the dais are available at training area. There you can collect that. And for our members, gifts are there. Those registered members of ACCE can get the gifts from this lunch is an interactive session. Wherever and whatever doubts you have, you can clear with the our guest speakers.
ఒకసారి వస్తే గ్రూప్ ఫోటో